Okay, let's continue with our conversation about electromagnetic waves, now talking about their energies. So, these waves can bring energy into a system, and this is by their electric or magnetic fields, or electric and magnetic fields. And these fields exert some force and can move charges in the system. Therefore, they can do work on the system. Okay, and the energy that's carried by a wave is proportional to its amplitude squared. So, for example, we have down here an electric field and a magnetic field. Okay, this will provide some energy, and if we take those two values and double them here, okay, so now we have 2E and 2B, we will get then our amplitude squared, meaning we will have 4 times the amount of energy now, since 2 squared is going to be 4. Okay, so we will have that idea here, and the larger electric and magnetic fields exert larger forces, therefore do more work. So let's look at this mathematically now. So, like I said, the amplitude is going to be the maximum field strength of the electric and magnetic fields. Okay, so this field strength values, those um, amplitudes squared are proportional to the energy carried and the intensity of the electromagnetic wave. Okay, like we said before, or I mentioned, that our electromagnetic waves are sinusoidal waves, so they have that oscillatory motion, like so. Okay, so this is our sinusoidal waves, and we can describe that having an average intensity, I sub AVG, is equal to C, our speed of light, epsilon naught times E naught squared divided by 2, where E naught is that maximum field strength, max E field strength. Okay, and then we can also put this in terms of the magnetic field instead, if we don't have that electric field value. So we can plug in our C is equal to E over B, and epsilon naught is equal to 1 divided by mu naught C squared. So we will say then I average, or the average intensity, is equal to C B naught squared divided by 2 mu naught. Okay, we can also write this as a combination of the two, which is E naught B naught divided by 2 mu naught. Okay, so let me write down this for us. That is our max B field strength. Okay, since these equations are based on the assumptions that these waves are sinusoidal, the peak intensity, I naught, is twice the average intensity. So just make note of that. Okay, again, the peak intensity, or that maximum intensity, I naught, is equal to 2 times the average intensity that we can solve for up here using either of those 3 equations. All right, so let's go to an example here. On its highest power setting, a certain microwave oven projects 1 kilowatt of microwaves onto a 30 by 40 centimeter area. The first question states, what is the intensity? All right, so intensity is power over area. So we have our power here, that is 1 kilowatt, so that would be 1 times 10 to the third watts. Then we have our area. Now we need to be careful because it's in centimeters, so our area should really be 0.30 times 0.40. That way it's in meters squared. All right, so let me quickly do that. Okay, so that is 0.12 meters squared. So now we can plug in to find our intensity. We have 1.0 times 10 to the third watts divided by 0.12 meters squared. And then we will get 8.3 times 10 to the third, yes, watt per meter squared. So this is our intensity of the microwave, okay? Now, we want to know the peak electric field strength. Okay, so let's go back. This is my average intensity, I'm going to say. We're going to use this guy since we're looking for this peak electric field strength. So I average is equal to C epsilon naught E naught squared divided by 2. And I didn't put anywhere in this PowerPoint what epsilon naught is, so bear with me. We have 3 times 10 to the 8th meters per second. I need to look that up. Okay. Let's see. Permittivity. Okay. I just wanted to double check my answer. 8.85 approximately times 10. Ooh, 10 to the negative 12. And this is in all kinds of units. I'm going to just write F over M. And then, oh, I was so distracted by what I didn't have. Forgot that we were solving for that guy. Divided by 2. And this is equal to that value there, 8.3 times 10 to the third watt per meters squared. All right, so we'd have to do some rearranging here. Okay, so we would have, if I go back to here, epsilon naught, we'd have 2 I average over C epsilon naught, all under a square root. Let's go ahead and do that. So we have that times 2, oh, divided by 3 times 10 to the 8th, times 8.85 times 10 to the negative 12, and then square root that guy. So we have an electric field strength, of 2.51 times 10 to the third. And electric field strength, I believe, is in volts per meter. Okay, so this is our peak electric field strength of those waves. Okay, now, so hopefully you followed my steps from here to there. If not, sorry. What I did is I plugged in my I here, my intensity, that 8.3 times 10 to the third value, my C, or 3 times 10 to the eighth, and then my epsilon naught, which is the 8.85 times 10 to the negative 12th. Okay, those are both constants. So that is my electric field strength. So now I want to know the peak magnetic field strength, B naught. So let's see. B naught is related to E naught. So let's see. Earlier we saw that E divided by B is equal to C. So this must also be true for our maximum values. So we must also have E naught divided by B naught equals C. Okay, so we can solve for B naught. That would be E naught divided by C. Our E naught we found is 2.51 times 10 to the third volts per meter, and our speed of light, meters per second. Okay, so we'll have that divided by 3 times 10 to the eighth, and I get 8.35 times 10 to negative 6, and that is in Teslas. Okay, so we've now found the maximum B value, or the maximum magnetic field strength, the maximum electric field strength, and our our average intensity of that microwave oven. Okay, so these are the types of problems that you would probably see. Something straightforward, just manipulating these equations. Okay, so maybe I give you the E field and the B field maximums, and you can find your average intensity. So you can do it this way. Actually, you can do it either of the three ways, or any of the three ways. Maybe I'll ask you what is the maximum intensity or the peak intensity, and so based on that information, what is our peak intensity, and so forth. Okay, all right, so that covers this chapter. Hopefully it wasn't too terrible, but next time we're going to go over optics, we're going to go over geometric optics, and hopefully we'll have some fun with that. All right, if you have any questions, as always, please let me know, and we'll see you in the next class.